2099. A train hurtles through a tunnel at a blinding speed, 5,000 miles an hour, on a journey through the Atlantic Ocean. Its passengers just had dinner in New York, and in less than an hour, they'll be having dessert in Paris. Science fiction? Perhaps not. A transatlantic tunnel may be closer to reality than we think. But just how would such a staggering project ever be built? Even if it could be completed, could it withstand the horrific dangers that would surely confront it? And if it is successful, could it provide the model for other tunnels that would one day link the people of the world across the 7 seas? Planet Earth. 70% of the Earth's surface is water. From time immemorial, the oceans and seas have been a mighty barrier, separating the peoples of the world. Over time, transoceanic travel has been mastered, but it is still not without difficulties. In the not-too-distant future, there may be a radical new way to cross the oceans, one that will forever transform life as we know it. More than 3,000 miles of ocean separate the old world from the new. A transatlantic tunnel would be the most massive construction project in human history, requiring global resources on a scale never before imagined. $1 billion tons of steel, the combined output of all the world's steel mills for an entire year. Over 50,000 tunnel sections, each weighing thousands of tons. Securing each to the ocean floor. The cost would be staggering, $12 trillion, and would take a century or more to complete, under some of the most extreme working conditions on the planet. But if completed, the transatlantic tunnel would change people's lives like nothing before. 60 million people cross the Atlantic every year. Most fly. And still it takes the better part of a day. A transatlantic tunnel would shrink that trip to less than an hour. One could easily live on one side and work on the other. An impossible dream? Frank Davidson doesn't think so.
Transatlantic tunnel is not beyond the reach of modern science and technology. It's a matter of getting used to new realities.
And Davidson should know. His firm helped design the English Channel Tunnel, linking England and France. The tunnel was also considered an impossible idea. And yet today, 6 million passengers a year make the 3-hour trip between Paris and London. But at 31 miles long, the channel seems little more than a short hop compared to a 3,100-mile-long transatlantic tunnel. The idea of a transatlantic tunnel has inspired visionaries for over a century. In 1895, Jules Verne predicted carriages traveling at 1,000 miles per hour, propelled through a tunnel by huge steam-driven fans at either end. In 1972, science fiction writer Harry Harrison envisioned a transatlantic tunnel partially supported by vast undersea bridges. Lately, engineers from Switzerland, Japan, and the US have proposed networks of underground tunnels to move freight below traffic-clogged cities. But constructing an underwater tunnel to carry passengers across the Atlantic would pose challenges of unimaginable proportions.
There are many factors that make it an extremely difficult, if not almost impossible project. The very limited weather windows for construction, the extreme distances that you'd have to move materials, and of course the cost of this enormous project.
Difficult, dangerous, astronomically expensive, and in the minds of some visionaries, altogether possible. When you start looking at the problems systematically, they will yield to research and development. The first critical step would be mapping out the most practical route. Since undersea construction can run as much as $4 billion a mile, the cheapest path would be the shortest one. An early proposal took the northern route, beginning at the edge of Canada's Newfoundland coast, then dipping in and out of the ocean, over Greenland and Iceland, before splitting toward Scotland and Norway. Compared to a completely submerged tunnel from New York to England, this route would cut underwater construction in half. But the problem is the overland portion. The extreme weather conditions during Greenland winters are all but certain to slow traffic due to ice and high winds. The best route may also turn out to be the most expensive. A straight shot 3,100 miles underwater from New York City to the coast of England, and on to London and Paris. But could it really be built? The classic way to build a tunnel is to dig. That's how the channel was made. In 1987, workers on the French and English coasts launched two huge drilling machines aimed directly at one another, each boring a hole 25 feet in diameter, 150 feet below the channel floor. 3 years later, the two teams met up at the midpoint, and the drilling was complete. But could engineers drill a tunnel under the ocean floor, all the way across the Atlantic? Unlikely. The tunnel took 3 years. At that rate, a transatlantic tunnel would take more than 3 centuries. And there's another problem. The channel lies only 300 feet below sea level.